So today's all about normal curve. We're going to look at, yes?
I don't think I was here when
You, okay, sweet. Have a look. The topic 3, let's see. So we need to do the normal curve tomorrow. Where are the ones? I got you. You've told me that before, and I think I was subconsciously choosing to participate. Okay, yeah. So we need to do it. Yeah. And it could be that's a dumb idea and we don't get to do that. I don't know. I was just trying to think how I could. Okay, so I really do need you to kind of put your thinking caps on, because when we had our Saturday session, we realized that sometimes when we try to find the standard deviation, we're not doing every step we need to do. And Sydney we had this, you probably remember this, and Laney. So let's just kind of go through this, and I'll tell you what I mean as we go. A certain population of whooping cranes migrate between Wisconsin and Florida every year. The sample of 15 male cranes were weighed before they left Wisconsin to begin their trip. The mean weight of the 15 males was found to be 22.7 pounds with a standard deviation of 2.3 pounds. And it asks this as a question, but let's just say this is normal. This is a normal distribution. The A question is, what is the probability that a random selected male crane weighs less than 20 pounds? What you looking for?
I need a packet.
Excuse me. I don't know if I'm sure I have. I ran off just. Let's see if I got more. There you go, but it seems like, there you go, I think that's it. Okay, so let's look at our question again. What is the probability that a random selected male crane weighs less than 20 pounds? Sketch the curve and put in all the appropriate values. Write the probability statement. So if you don't care right now, please underline what's being talked about. So what is being talked about? A random selected male crane. So that A lets us know, among other things, how many cranes are we looking at? We're looking at one crane. That's going to be critically important when you go to calculate your standard deviation. So before you start to try to figure out your standard deviation, underline what you're talking about. So the standard deviation for this is just going to be the 2.3, and if you want to think about it being divided by the square root of 1, that won't change anything. So your standard deviation is still 2.3. And I want to direct you to where you can see it on your formula sheet. It's under inferential statistics, sample mean, and did you see what I did? My N was 1, so it was just whatever was listed. Go back. Now that we've got that out of the way, let's go ahead and sketch is it asked for a sketch. The mean weight is 22.7. And what is the probability that they're going to weigh less than 20 pounds? We okay with the sketch part? Now we're in our probability statement. So I'm going to write my probability statement this way. Probability, male crane weighs less than 20 pounds.
Can we do like X bar?
You got to be careful because this one's not an X bar, but you can. So, and that was my next thought, Sydney. If you remember our conversation Saturday where we were talking about notation, this one's an X because we've only got the one. We didn't take a sample of any cranes. So, if you had put X bar there, you're going to get deducted a little bit. Whereas, if you just write the words, and I choose to just write the words, and then that takes notation off the table. If you do decide to do that, just go back over here and look and say, okay, I just have one. X bar is for a sample. X is for a one thing. So that's a really good question. But you do have to have a probability statement. I just prefer to write mine out.
Would you suggest to write it out like so?
I would. Is it that complicated to think of just X? No, but somewhere you got to write out what X is anyway. So, and so, of course, we're going to do normal CDF, and normally I would finish it up here, but I just ran out of room, and we're going to go from a very low number to 20. There's my mean and my standard deviation, which I discussed earlier. And you always do normal CDF when you have boundaries and you want area, which is another way of saying probability. So I had boundaries, that let me know that I'll need to open up normal CDF. If you get confused between that inverse normal, open up inverse normal. You'll see that your information doesn't fit what the calculator is asking you for. I got, let's see, what did I get for this one? I got 12/100, 12%. So let's see if I've done everything they asked me to. I found the values, I sketched the curve, I wrote the probability statement. Now let's talk about AP land for a while. What fatal mistake have I made?
Didn't label.
I did not label. So I've got to label lower bound, upper bound, mean, and standard deviation. Now, we also had a long talk about finding your z-score. The last I heard from the AP readers is as long as you label your normal CDF statement and you draw a sketch, you're covered. You've got it. Now, could you have found a z-score if I asked you to? If you forgot how to find z-scores, that's also on your formula sheet. X minus X bar divided by the standard deviation. You can go through and real quickly find your z-score if you want to. And you need to know how to do it, but not necessarily here unless you choose to go that route. If you decide to do z-scores right here, what needs to be your mean and standard deviation? 0 and 1. So just, you've got to make that decision about which one you're more comfortable with. If I had to recommend, this is how I do mine. But maybe that clicks another way for you. That's up to you. Okay, so the B part, what is the probability that a random selected male crane weighs more than 20 pounds? So our sketch would look like this. Need a probability statement. Weighs more than 25. And I'm gonna go below it. You could have written it this way as well. If you wanted to do exercise. And for that one, I've got 1.59 is the answer. Let me start circling the answers so they come. Where are we at so far in this normal curve? Is this kind of, if you were here Saturday, we hit it pretty heavy, but everybody else, Braden, is this okay? Is there anything about this that we need to go into more detail about? Let me ask you just a side thought. Do you typically go ahead and find the Z-score anyway, or you just do label the normal CDO and do the sketch?
I'm doing like a test, I would find the Z-scores.
And if you remember in the back of our book, where we write in the probability statement, they would use the Z, so. All right, let's find this next probability when we know the probability that, again, A, so our standard deviation is still just going to be the 2.3. Our mean is, it's important to label your mean as well. 21 and 26 are our upper and lower boundaries. If y'all don't care, I'm going to leave off the probability statement on that and just give you what I got as a result. This one's me. I always like these because my lower and upper bound is so. D is where we're struggling with. After looking at the mock, D is where we really don't have to do just a little bit of work before we take the real one. So if you don't care, let's look at D together. When these cranes reach Florida, another random sample of 25 male cranes is weighted and measured. The mean weight is recorded at 19.5 with a standard deviation of 1.7. Using this sample statistic, make a prediction about another sample of 25 from the same population. What is the probability that the mean of samples will be between 15 and 22 pounds? Okay, means 19.5. I'm good with that. What do we find in the standard deviation of? That's the question we've got to ask. Before it was the standard deviation of a crane. What do we find in the standard deviation of now? Beautiful. We're finding the standard deviation for that mean of the samples, which was 25. So, if you go back to your formula, is our standard deviation going to change a little bit? Yeah, because we've got to divide through by the square root of the sample size. So we're going, let me come out here and do my standard deviation. It was 1.7, but if we're only doing that, I got 34 hundredths. Did anybody else get that? So I sketch 15 and 22 are my lower and upper. 19.5 is my mean. We're doing the mean of the samples between 15 and 22. And Sydney, here's where your X bar would have come in. If you decide you want to do this notation, just do the probability that X bar is greater than 15, less than 22. Pick your method, and then it'll again be normal CDF, lower, upper, mean, and your standard deviation for your sample. If you think about it conceptually, it makes sense. of why your standard deviation needs to be adjusted by the square root of the sample size. Just underline what you're taking the standard deviation of is my suggestion. If it's just 1, it'll just be what they gave you, and if it's more, then you'll adjust. I'm going to let you do E and F on your own because it's worked the same way. That probably be a good check to make sure you got this. E is approximately 0, and then F, I got 5 zeros and then 5. So that's probably really similar to what your quiz will be like tomorrow, which will be but a normal person. Is anybody confused about when to just go with the standard deviation they give you and when to divide by the square root of the n? Okay, so on the proportions, this one's dealing with the proportion. The Helsinki Heart Study asked whether the anti-cholesterol drug, we're going to call that GEM, will reduce heart attacks. In planning such an experiment, the researchers must be confident that the sample sizes are large enough. They plan to give the drug to 2,000 men and a placebo to another 2,000 men. The probability of a heart attack for this for the study for men this age is about 4%. We're going to consider this a simple random sample. What does just P stand for? We got a P, and then sometimes you see a P hat. What is the difference between those two? If something is wearing a hat, it means, in this case, we're looking at a sample. The plain P is the notation for population proportion. So, if you're on the test and you need to say, hey, this is my population proportion, and you can't remember, write out population proportion. Don't try to get fancy with notation if you can't remember it. And here, if you just want to say sample proportion, say it. Don't if you can't remember the notation, but that's the distinction there. So what is the mean number of heart attacks that this study will find in a group of 2,000 men if the treatment doesn't change? Well, what we know from proportions, the mean of the proportion will match the population proportion. So we're looking at that 0.04 or the 4%. But they didn't ask for that, they asked for a number. So to get a number, you have to multiply that by the 2,000 men in the study, which will give you 80. So the mean number of heart attacks we'll find is 80. And do you have to remember that? No. If you want to remember that tidbit about the proportion, it's actually on your formula sheet under probability, and it tells you it lists. You can't see it, but that's what it looks like, and that's why I knew that the population of 0.04 was the mean they were. I knew that. What is the probability that the group will suffer at least 75 heart attacks? I'll do my sketch over here. We've already said that we can say the mean is 4%. What might I want to do to that 75? If I'm looking at percentages, I want to change that to a percent or a decimal, so I can do 75 divided by 2,000, and you get 0.0375. At least so now I have lower bound, upper bound, I have my mean. I'm missing something. What don't I have that I need for normalcy here? need your standard deviation. And the standard deviation is handled a little differently with proportions, but luckily you don't have to, you just go to your reference sheet, standard deviation, sample proportion, there's your formula. It's irrespective of whether there's one in the sample or it's different than me. You don't have to go through that thought process. So here's the formula for standard deviation. I'm going to do it in blue. It's your P, which we already said was 0.04, 1 minus P, divided by your sample size. And it gives you this number. Lower bound, upper bound, main, standard deviation. And I got this number. And if anybody crunches that and gets something different, then tell me, but I'm pretty sure that's.
I think it's 20.
0.71, and that's around there. Now that was a proportion, so that one, your standard deviation is handled differently. We're going to talk a little bit about 25, and then we're going to stop, and I'll let you finish this 25, 26, and 27 up. Children in kindergarten are sometimes given this matrix test to assess their readiness for learning. It has a mean of 13.6, standard deviation of 3.1. We're going to approximately normal, and there's 22 children. They had to say it was approximately normal because according to the central limit theorem, what number were we looking for? 30, and since it wasn't 30, they had to tell us something. So what is the probability that the class's mean score will be less than 12? At some point we're going to need the standard deviation here. The standard deviation of what? Is it a kindergarten student, or what is it? What are we wanting the mean of?
12.
Do what? Yeah, we want the standard deviation of the distribution of 22 children. So when I go to get the standard deviation, so every time you have to find the standard deviation, ask yourself, what am I finding it of? You're actually going to have to go through a z-score on one of these, but I'm going to let you kind of puzzle through this, and if you need help, I'll be glad to do that. Quiz tomorrow on what we discussed today.